Welcome everybody to another Coding Cleverly video. Today's topic is about another sorting algorithm. In the previous video, or in the previous videos, we've been doing sorting algorithms, and the first one that we came across was basically the selection sort algorithm. And then we went to bubble sort, and then we went to insertion sort, and I had all the code linked to my GitHub repo so you could check it out. And today's video is going to be specific about one other sorting algorithm, and that's known as merge sort. And it's really special and it's different from all the others. So what we're going to start out is basically include our header files. I have my IO stream over here. I have my namespace. I have my integer main, and I also have my return 0 semicolon right there. Okay, so what I want to do here is I want to implement the merge sort, and I'm going to explain it side by side as well as the explanation at the end. So before all of this, let's create the function. So the void merge function is basically going to have some really simple stuff. So I'm just going to call it merge sort, and what it's going to get is like the conventional array that it's going to sort, and it's going to get the size of that array. So what it's going to basically do is it's a wrapper function, and it's going to call another function inside. So it's going to be a different function in place of this in the code. So it's a, and it's going to start from 0, and it's going to go all the way to n-1. Now hold on, you understand all of this. Just wait and start and type with me. So basically void merge sort, and this is the real deal. So this is basically the auxiliary function. This is the wrapper function, what we could say. So over here we have that same array. We have basically the start, and we have the ending of it. Okay, so now over here is the main implementation to the merge sort. It's going to be inside. So before that, let me basically have an array over here defined. So I'm just going to create a random array, and I'm just going to give some random size. So yeah, let's just give some random size. That'll do. Now what we want to do is basically compute the size, and we're going to do basically simply have the array, and then we have the size of the data type. So it's int, so it's just going to give the size over here. Now we have to call it through a show function. So we could have a show function implemented here, which is going to accept an array. It's going to accept the size of that array, and what's it going to do is it's going to display the contents of that array. So let's say that we start at index 0, and we have a loop that reaches the n, so over here, and now we could just basically console output the value of that number and put a comma right here, and just increment the value, and also over here let's just give it an end line. Okay, so this is my show function which is generated, and I have an array, and I also have a size. So basically I could call my show function, so I could just say show, and I could just pass in the array, and I could pass in the size, and what it's supposed to do is show the function to me. I don't have anything inside of this, so I believe that there's not going to be any problem here. So I'm basically going to get my array printed out. So let's see if I run this code, and you can see that the array is printed out as 0, 1, 2, 3, 4, 5, 6. Wow. Now, why is this appearing? Because the contents of the indices are being placed and not the values. So it basically needs to have a sub I. And now, if we print this out, we're going to have the contents instead of the indices. All right, so this is the contents that are placed. Cool. So that's about it. Now let's go and understand what merge sort can do and how it does work. So look over here is that I have a sketchbook created, and I have basically is one portion of the array. So what we're going to assume is that this is a single array, and we want this sorted. Now in some case scenarios that we have this part is sorted and this part is sorted. So they're exactly one single array. It's one array, but the first half is sorted as in ascending order, and the second half is sorted in ascending order, but they're basically independent and they're not depending on each other. So you can see that there's like a cross, but actually they're the same array. And you see that 2, 7, 11, and 13, okay, that's in order. 3, 4, 5, and 15, that's also in order, but as a whole they're not in order. So you could do one option or one solution if you want to sort this array is apply another sorting algorithm like insertion sort or a merge sort, a bubble sort or whatever, selection sort, and that will give you the result. But that's not what we want, and that would take really long time. Instead, we could have a better approach, and the better approach is to apply a new algorithm, and that algorithm is called merge sort. So what we do is basically we merge. So yeah, you got to bear this writing. So this is the merge. We're gonna apply a merge concept here, and how it's gonna do is basically compare these two, and it's gonna create, I would say, there's gonna be another array inside the memory, and what's gonna do is basically compute the first value over here and the first value over here. So it just says 2 and it checks for 3, and it checks which one is smaller. So we know that 2 is smaller than 3, so 2 is going to be added over here. Okay, so once 2 is added, we increment this portion, so this part will be incremented, and now it's going to check for 7 and 3. So which one is smaller? 3 is smaller, so 3 is going to be placed here. Now 3, this portion is going to be incremented, and 4 is going to be over here. So now it's going to be checking 4 and 7. Now you can see that 4 is smaller, so we basically say 4 is going to be implemented here. Now once 4 is implemented, now we can say that 5 is going to be added. So now we're going to check if 7 and 5, so basically 5 is implemented, so 5 is going to be added over here. Now we're going to check, and it's going to imply over here with 15. So we're going to check over here with 7 and 15. Well, 7 is smaller, so 7 is going to be added over here, and now 7 will be implemented over here to 11. So we say 11 and 15, and now we know that 11 is added over here, so 11 is going to be added. Now we could just increment this over here to 13. So we know that 13 and 15, so we know that 13 is smaller, so we could just say 13 is over here. And now once we know that the contents of this is done, so these are all complete, right? So what they're complete, so this is automatically going to be appended at the end of the new array. So basically the contents, whatever it was, if there was, this is single one over here in this case, but in other cases, if it was like 10 or like 20 elements that were remaining, or there was more than that or less than that, then all of them were just going to be appended at the end of the array. So basically this 15 is going to be placed over here. So now if I take a look at this array, so if I take a look at this, now this array, 2, 3, 4, 5, 7, 11, 13, 15. Wow, this is sorted. So we basically solved our problem by sorting this array, and this basically took lesser computation time, lesser processing power than compared to other sorting algorithms. And this process took the order of n log of n. Now n log of n is pretty slow. If I talk about n log of n, my bad, is not pretty slow. It's super fast as compared to algorithms of n, I would say log of n squared, which were merge and others. So this is the process how we're going to implement it, and let's get started by basically having the function defined inside of our body. So over here we have the merge sort, and inside we have an array. We also have the starting value, we also have the ending value. Now what we have to do here is that we have to do if. Now the condition is that if we have the starting, which is greater than equal to the ending, all right? This is a base case. How we're gonna apply this process is known with recursion. And recursion is basically the task that is gonna allow us to solve this whole process. We're gonna have to trust on some process, and that is that how the process that how we're going to trust is that how do we know beforehand that this portion is sorted and this portion is sorted but the whole is not sorted? That is through recursion. We're going to have to trust and put faith to recursion, and that would help us with sorting this algorithm. Now the thing that I want to bring up is that we have S. Now S is the starting point, and we could just put it over here as this, and E is the ending point. We could just place over here. Starting and the ending. Now the other thing that we have to look towards is that we have this middle point that we're going to have to cut to make it half. So we have the first half was sorted and the second half. So this is the base case, and I would basically return this. So if this is basically not physically possible, it means that the starting is greater than equal to the ending. Now the starting is basically one portion, and it can never be greater than the ending, right? It could be equal, but if it's equal, then the process is finished. So if it's less than, so if the starting is less than ending, then the process should go, right? So what we're gonna do here is now we're gonna have this else case, and let's create a midpoint. So to create a midpoint, it's really simple. We're basically having the starting and the ending, and we divide it by 2. Once we divide it by 2, we have our answer. Now we could say merge sort, which we're gonna basically, like I said, we're gonna be implementing that recursive process, which is gonna have the first process, which is gonna be the array, the starting point, and the ending point. Now, ending point over here is E, right? But in this particular case, when I split the array, so I split the array, and we had 2 portions, and this was the midpoint over here. So if I split this array 4 and 4, and I have this portion over here, so this is gonna be basically my M portion, middle portion. Now to get this, I could just divide, so I could just add the 2 contents, so I would say starting and the ending, and I would just divide it by 2, and once I get like the portion, so I would just say something like, which is, I would say 0 index is over here, and then I have this 7 index over here, which is over 0, 1, 2, 3, 4, 5, 6, 7, and when I divide that with 2, I'm basically gonna have integer division. So it's basically gonna allow me to have like 3, so 0, 1, 2, and 3. So this is the third portion, and this is gonna be my M right here. So that's how it's gonna be implemented, and what I could do is now apply that within my code. So let's have that M over here, and now let me just hit a semicolon. Now what we could do is merge sort, and we could have A, we could have M plus 1, and we could have the last ending over here. Now what does that mean is that we got the same array, but now we're gonna apply from M plus 1, which is this portion over here. Now we're gonna start from here till the end. First we sorted from here till the M portion, and now we're gonna go from there and there. So it's gonna basically sort the 2, and once I get this hooked up, so if I go back to my code over here, and now I basically apply this combine, which is the last process to make them 2 combined. So this is the array, it's the starting, it's basically the mid one, and then the end one. And this has 4 arguments, and we're gonna tell how to do this. So this process over here is basically recursively sorting the first half, and the second process is recursively sorting the second half. And then when we have this function over here, this is gonna be combining. So let me just type this in, combining the first and second half. Okay, so let me just fix this up, combining, there you go. So this is how the process is gonna be. Now what we have to do is we're gonna have to find the combine function, and how do we implement the combine function. So let's go ahead and start writing our combine function on the top. So over here on the top of the screen, what we're gonna do is we're gonna have the combine function defined. So void combine, and what the job of the combine is to just basically combine the 2 sorted arrays into one whole. So we have, I would say, the array, and then we have the starting point, which is S, the middle point, which we just calculated inside of the merge sort function, and the ending point, which is E. Okay, now inside of this is that we have to create a buffer point. Now I told you that we can't basically sort our pre-existing array. We're gonna have to create a new array, and we're using pointers. So we're using a pointer buffer, and it's called pointer to int buffer. And what it's gonna do is basically I'm gonna allocate some data from the heap, and it's gonna get a memory location which is +1, more than the existing array. So you can see over here, this is actually a new array. We're not creating and sorting inside of this same array. We're basically creating a new one. To create a new one, we're gonna have to reserve some memory from the heap, and then after that, what we could do is basically this is gonna be our buffer one. So if I go back to my code, this is my buffer one, and my original one is A. So what I could say is that once I want to copy all of the content to here, so I could just basically copy the content to my buffer, and then I could just call this as the buffer, the copied content, and my new will be called A, the sorted one. So that kind of approach what I want to apply, and I'm sure you will understand this once this video is finished. So let's go and now finish this up by using a K variable. I want to save the value of S, which is the starting point, and I'll save that in K to further apply some rules with it. So the first rule that I want to apply with K is that if K is less than equal to E. Now this is the ending point. Now what's going to happen is that it wants to copy all the contents. So buffer sub K is the new thing, and we're going to assign the values of buffer sub K to the buffer sub A, and we're just going to increment K with the K plus 1. And then once we're like copying the whole thing, the buffer will contain some values as of A arrays. So, and then later the original array will be the sorted one, and that's how the process is going to be made. Right after this is when we want to combine the two parts. So this is the process and where we're going to combining the two parts. Now, how am I going to do is basically I'm going to have I is equal to S. I'm going to have another integer j, and I'm going to get that as the midpoint plus 1. And what is going to happen is that K is going to be the starting point. So let me just show you what's going on here. We're going to have a variable over here, and over here is going to be called I. Okay, and it's going to point the first one. Over here at the bottom over here is going to be called j. It's going to point to this one. And over here is M, we already know that. And over here is K. So this is basically our sorted array. I would just say this is A, and this is going to be buffer. So this is buffer, B for buffer. Now, if I go back, what I'm going to do is I'm going to have to apply this rule that's called if I is less than M, and you know M is right in the middle, right here, M. It's less than M, right? So if I is less than M, and if I see one more thing, which is over here, ampersand, and I say j is less than equal to E, which is the last one, because j is basically going to start from the midpoint. So let me just correct this. I made a mistake over here. J shouldn't be starting over here, but j should be starting from M plus 1, so right here. So if it does not reach the last element, which is E, so E was over here, and if it does not reach there, continue this process. Okay, so let's go back to our code, and let's have this if buffer sub I is less than equal to buffer sub j. So if this process is correct, you mean if sub I is less than or equal to sub j, what we could say is A sub k, the new one, will have the buffer of sub I. And then what we do is basically implement a plus plus over here. All right, so after that we could say else. Now, and the else portion we could have is A sub k. If that's not the case, we're gonna have A sub k with the buffer of j. And we're going to increment j with its variable. So j is going to be incremented with its variable, and once j is incremented, we could have k incremented as well. Because if I look over here, k is from here, and it's just going to go all the way to the end. While when we did this process of going 2, and we just basically selected this portion, and we checked which one is smaller. So we saw 2 is smaller, we added over here, and then we incremented the process, and basically now this I portion was incremented to this j location. So then it was checked through that if 7 and 3 was sorted. So basically it saw 3, so it added this, and then incremented the j portion and went to 4. So it's just, you could see that the process is working. We're writing the code that implements that same algorithm, and that's what you have to do in software development. You have to understand that logic. So once we're understanding the logic, we basically have to implement the code, and that shouldn't take that long. So right after this is now a while condition. Now the condition here is that if all of this is done, there might be some portions, like, remember I told you that there's going to be a portion over here that was remaining, and then we automatically append it at the end of that new array. For that kind of portion, I'm going to have this 2 while loops that I'm going to be implementing here. So the first while loop I'm going to be saying is that if I is less than or equal to m. Now this was my first condition for my upper while loop, which is over here, I is less than or equal to m. My second one is j is less than or equal to e. So over here is going to be a sub k, which is the new array, and I'm going to say the buffer, which is over here, and the buffer sub whatever the ith value was there, I'm just going to append it. I'm going to increment that value with plus plus, and I'm going to increment the value of the k with plus plus. Okay, so another case, if it's while j is less than or equal to e, we're going to have the same procedure, which is a sub k, and we're going to have the buffer, and we're also going to have the j. So we're going to have the incrementation of j plus plus, and we're going to have the e plus plus. And sorry about the e plus plus, but actually the k plus plus, because e is basically the endpoint, and we don't have to do anything about it. The only thing that we have to traverse is basically the k. So it's fine with the j and the k. So this is j over here, and then the k over here. Now, once we're done with this portion here, we're going to have to basically deallocate our dynamic, I would say, memory. So which is delete, and then we have this portion over here, and then we call the buffer. So this is going to delete our dynamically allocated array from the heap. So this is going to delete it, and then basically I'll just show you that this sorted thing will be called our A, and this is going to be deleted from the memory, so it's going to be gone, wiped out, and we're not going to see its existence. It's not going to harm the memory. Okay, so after that, what we're going to do is basically now implement that code inside of here. So we have this array. Let me pass it into merge sort. Now merge sort is going to accept an array and also the size. And now we're going to show it again. So we're going to have the array, we're going to have the size as well. So once I run this code, I'm going to see that array going to be sorted. So let's see. Okay, so we have 139, 193, which is the unsorted array. When you pass into that merge sort function, we got 1155, 139, 193, all of that sorted. So that was pretty much it with this video. The code to this is going to be linked in my GitHub repository. Also in the comments, you could check it out. I also pinned it, so you could just copy it, modify it, and do whatever you would like to do with it. More with that, I would like you to subscribe to the channel to continuously support it and make me motivated to provide you much more videos in the future. And apart from that, thank you so much for your support. It really means a lot. And that's it from my side, and I will see you guys in the next one. Peace out.